Hello, everyone, and welcome to the first class in Florida Data Science Academy's 24-part series, Introduction to Data Science. I'll be your instructor, Dylan Sinnickson, and today in class one, we'll be going over all of the basics of RStudio. In particular, how do we write basic forms of code, and also how do we move throughout the interface. So the first thing that I'm going to do today is create a new R script. So to do that, I'm going to click on the File tab. I'm going to click New File, and then I'm going to move and click our script. And then you can see a new window opens up in the top left-hand portion of our screen. It's currently called Untitled 1. We haven't named it yet. And this is where we're going to write our code, and then we're subsequently going to save this code. So the first thing I'm going to do is write a comment to myself. So if we want to write a comment to ourselves, we hold Shift and the number 3. That's going to give us the comment or pound symbol. You can see that the text is green. I'm going to type intro to R, and then I'm going to give myself, click the Enter tab, and we're going to give myself a little bit of space, move down to line 2, and then I'm going to type, what is the console? So what is the console? Well, the console is the bottom left-hand portion of our screen. So this is where we're actually going to be doing all of the computation. So we're going to be writing our code in the R script, and then we're going to be actually calculating the values in the bottom left-hand portion of the screen, which is the console. So the first thing I'm going to do is work with a couple arithmetic examples. So let's just start off with a very basic example, 2 plus 2. So you can see that when I type 2 plus 2, we don't immediately get an answer. We have to actually run our script, our code, in order to see what the answer is. So if you want to run code in R, there's a couple things you can do. First of all, you want to put your cursor on the line of code that we would like to run, and then you can click the Run button, which you can see right here. And when I click Run, we can see that in the console, our calculation is being conducted, where we have our code in blue text, 2 plus 2, and then our output, which is going to be in black text. So we see that 2 plus 2 obviously equals 4. So the first way that I showed you how to run code is to click the Run tab, but I can also use another keyboard shortcut. If you're working with a PC, you can hold Control and Enter at the same time. And you can see that we, again, do the 2 plus 2 equation and get an output of 4. So the two ways of running code in R that are very simple are putting your cursor on the line, clicking Run, or you can put your cursor on the line and hit Control and Enter, and we get this. Obviously, we get the same answer. So I'll move on to my second arithmetic example. I'll do 6 times 6. So if you want to use the multiplication symbol in R, that's going to be an asterisk. So that'll be holding Shift and the number 8. We get a little asterisk symbol, which signifies a multiplication symbol. And we can hold Control and Enter on line 5. And we can see that 6 times 6 indeed equals 36. And then I'll move on to a little bit more of a complicated example. We'll do 10 times 5 in parentheses, and then we'll add 5. So again, in R, the same PEMDAS principles apply. We're going to do all the calculations in the parentheses first, and then we'll work outside of the parentheses. So we can run 10 times 5 plus 5, and I can click Run, and we see that we get an answer of 55. So those are just some basic arithmetic examples that are particularly important. But as you can tell, when we ran code in all of these examples, we put our cursor on the line and clicked Run, or we held Control and Enter. But something that can be a little bit quicker, especially if we have very long R scripts, and it's very common that a professional data scientist will have R scripts that are hundreds of lines, if not thousands of lines of code. Obviously, you're not going to want to click Run 100 or 1,000 times. Something that's much quicker and more convenient is that you can actually highlight all of your lines of code of interest that you would like to run. You can hold Control and Enter, and you get all of those calculations being conducted again. Or you can, again, highlight all of your code, and you can click Run. And you can see that all those same calculations are being conducted again. So just another topic I'd like to mention is that when you have code that's commented out in green, you can see that we're not, it shows up in the R console, but R is not actually running any of the code that's commented out when it's in green text. It'll show up in your console, but it's not actually doing any calculations. So now we're going to move on to another section of today's course. I'm actually going to give myself a little bit of space in the console. You can see we've done a couple different calculations, but I want to give myself a little bit of space. So I can actually click the Enter or the Tab, and we can see that we get a little bit more space, which helps my R console to be a little bit less cluttered. So now I'm going to move on to another section in today's course, which is going to be called What is the Environment? So what is the environment? Well, that's going to be the top right-hand portion of the screen. This is where we're going to store our objects. So if you're not familiar, R is an object-oriented programming language, which essentially means that we're going to signify certain values or equations or functions and store them as objects. So objects or phrases are going to symbolize numerical expressions. So what I'm going to do is I'm going to start off by creating an object called year, and I'm going to set it equal to, and you can tell that to set something equal, set an object equal to a certain value, we're going to use the less than sign followed by a dash. So it's this little arrow. I can use the equation, the equal sign, but we're not going to cover this topic in today's class, but you'll see in later classes that when you use a double equal sign, that can a single equal sign and a double equal sign will mean different things. So I think it's more applicable if you want to set an object equals to a certain value to use the less than symbol followed by a dash. So currently I'm working in the year 2022. So I'm just going to type 2022 on line 10, going to click run. And then you can see in my R environment, there's an object called year set equal to 2022. And then I'll create another object. This time it'll be states. So I'll set states equal to the number 50. There are 50 states in the United States. And I can click run for line 11. And we can see that in our R environment, this object called states is being created and stored here. It's equal to the number 50. And then we will create an object called Dylan's age. My name is Dylan. I'm a little bit over 30 years of age. So I will create an object called Dylan's age, and I'll set it equal to 30.2. I can hold Control and Enter, and we can see that in our R environment, there's an object being created called Dylan's age that's equal to 30.2. So now I've been demonstrating how these values are being stored in the R environment, but we can also print out these values to actually see what they're equal to. So if I want to print out a value, I can go into my R script. I can, for example, work with the first object, which is called year, and I can just run line 14 year. And we can see in our console that the year object is equal to 2022. So when we just run a line of code that has our object with it, we actually just print out the value. We can do the same thing for states. We can click run, and we see that the states object is equal to 50. And lastly, let's work with Dylan's age. So you can see that when we actually type Dylan's age, there's this little purple tag that shows up. So I can click Dylan's age. So it already understands that there's an object called Dylan's age. I can click on it, and I can hold Control and Enter, and we can see that an object indeed exists called Dylan's age, and it's equal to 30.2.